Okay, welcome back to Grade 9 Academic Math Online for the Thames Valley District School Board. And we're looking at a new unit right now, Algebra. One's favorite. Algebra, U2A1 and U2A2 video. Real quick, this will be an easy one I think for most of you. We'll just talk about like terms, collecting like terms, coefficients, variables, monomials, binomials, and that sort of thing. So when you have a term, something like 2x, we call that a monomial. If you have a couple terms, like 2x plus 2, I don't know, z, these two terms are different. And because they're different, we call this a binomial. Binomial. And monomial was 1, binomial is 2, 3. Trinomial, so if you have 3 terms, so if I throw in a -6 maybe in front of this whole thing, then you have 3 distinct terms. And how do you know the terms are different? Well, they have different variables. So let's go back to the monomial. First of all, the 2x. 2x is made up of 2 little pieces here. One is the 2 and one is the x. This is what we call the coefficient. And that's doesn't like to get, that's his coefficient. And here this is the variable. And the difference between the two is that the coefficient is always the same and the variable can change. So the coefficient in this case is +2, and it is always +2. So 2 tomatoes is 2 tomatoes is 2 tomatoes. And you always have 2 tomatoes. You have 2 eyes, 2 ears, and 2 x's in this case. And what is x? Well, that depends. And that varies depending on what you want it to be or what this scenario makes it to be. So that's a variable. X, z, x squared. We represent them with letters. X is our favorite. X and y are our favorite usually. And variables are different if they have different letters. So x and y and z. For example, they're different, but they're also different if you can if they're a different combination of letters. So if you have x, y, that's different than z, p, for example, or x, z. Be careful though that x, y, and y, z is equal to. Sorry, that's not true at all. Y, z is equal to z, y. So you can rewrite these things in different orders. And as long as they're the same letters to the same power, which I'll get to in a second, you are okay with saying that they are equal to each other. Because when you put letters side by side, I just paused for a second there. When you put letters side by side, you're saying x times y, xy is x times y, and that's the same as y times x, right? So if you had 2 times 3, that's the same as saying 3 times 2. They're both equal to 6. So order doesn't matter. But variable and variable power matters. So for example, x squared y is not the same as xy squared, because you have x times y for x squared y, and this is xy times y, and those are not the same. So those are not equal. So we're talking about monomials, binomials, trinomials. In general, we call them polynomials. So if we talk about monomials together with trinomials, or we don't know with the scenario, you may use the word polynomial. Poly from the Greek meaning many, actually. And so that's just a little intro. And what we're going to do is collect like terms. So if you have 2x and 3x and you add them together, you have an x and an x, and you have an x and an x and an x. You have 2 x's and you have 3 x's, and together you have 5 x's. So what you do when you collect like terms, you add the coefficients or the constants together. So it's 2 plus 3, and you leave the variable as is. Don't make that x squared, don't make it 2x or any combination. It's like you have 2 bananas and you have 3 bananas. You have a bunch of fruit. No, just kidding, you have 5 bananas. Okay, you don't have 5 banana squares or banana squares. That sounds good. Anyway, you don't have that. So there's that's scenario. The other thing you might want to do, and when we get to 2.3 or 2.2, sorry, is collecting like terms where they're separated by brackets and that sort of thing. So I'm going to put something together here, and you have something like this, and we'll collect like terms here. Let's see what happens. Okay, so you got 2x and 3 plus 3x squared plus 3yx, and usually we don't write that way. Usually we go in alphabetical order, so 3xy is the way you write it, but that's fine. 3yx, and here you have to subtract this whole thing here. So what you're going to do is look inside each bracket and try to simplify each bracket first, and I can't do anything here. X is different than x squared, is different than yx, x is different than y squared, which is different than yx, so I'm done with that. Then you have brackets. So my rule of thumb, and it'll come up in a bit, is whenever you have something in front of a bracket, or anytime you have a bracket, you open it up, you get rid of the bracket, you multiply everything in the bracket by everything outside the bracket. Now, if you look here, there's nothing in front of the bracket, so really there's a number 1 here. So when you open this up, it's really simple. You multiply everything by 1, or you just leave everything as is. Okay? So this is equal to, get used to using the equal sign, that. Here, a little bit different. You have a negative in front of the bracket, so it's really a negative 1 in front of the bracket. So you have negative 1 of all of this, or subtract all of this. So if I'm going to subtract all of this, that means I'm subtracting x. I'm subtracting negative y squared, so that means I'm adding y squared, and I'm subtracting 2yx, or make that a negative 2yx. Another way to think of it is multiply everything in the bracket by everything in front of the bracket. So I have a negative 1, so negative 1 times x, negative 1 times negative y squared, negative 1 times plus 2yx, and now I am done. Oh, I grabbed the wrong pen, but that's fine. So now, a couple ways you can rearrange and group if you want. Another thing you can do is just circle or identify like terms. So I don't mind this at all. If you want to just circle or identify like terms by circling or underlining or something like that, sometimes that's easier. I'll do both here. So what I'll do is I'll look, my first term is an x. I have an x over here, so I have 2x, I have minus x. Then I have an x squared, so I have 3 plus 3x squared. Maybe I didn't use the right pen for that, but that's plus 3x squared. I don't have any x squareds there, so that's fine. My next term is plus 3yx, and I do have negative 2yx over here, and that leaves me with this guy right here. So I could collect the like terms and add them together now, or I could group. And grouping means actually write the terms that are like beside each other. So I have my 2x, my underlined 2x, and I have my minus x. Then I have my minus 3x squared, and I have nothing with that. Then I have plus 3yx, and I have another negative 2yx. And notice that the sign goes with the number. So I don't have 2yx, I have negative 2yx. So that's done, that's done, that's done. I got rid of that. I already used the negative x. I'm left with this right here. Now the terms that are like are near each other. So these two collect. I have 2x minus x. That leaves me 1x, or just x. Minus 3x squared. I have 3yx minus 2yx, which will give me 1yx, or just yx. And I end up with my y squared. Okay, and that's it. So that's 2.1, 2.2 in a nutshell. Take care. Man, I'm just going to hit stop. You're probably seeing this.